All right, here we go. The review packet key. Make sure you do your work first and then come back and check me only when you're stuck. All right, we have a standard form quadratic equation. So when I want to find my domain, all real numbers, negative infinity to positive infinity, I don't know my range until I can figure out what my vertex is. So when I look at my vertex, negative b over 2a is going to help me find the x coordinate. Here's my a value, here's my b value, here's my c value. So I know that negative 8 over 2 times negative 2 is going to be equal to my x. Negative 8 over negative 4. So the x coordinate value of my vertex is 2. My axis of symmetry is 2. And I know that my parabola centers on this axis of symmetry, and the vertex is somewhere here. When I want to find the y-coordinate, I've got two choices. I can substitute 2 into the equation and solve. Maybe what I'd rather do is go to my graphing calculator and say negative 2 times 2 squared plus 8 times 2 minus 5, positive 3, which means the vertex 1, 2, 3 is at this point. Instead, what I might have done is go to my function screen, negative 2x squared plus 8x minus 5. Looking at the graph, I can see I'm in the right area for my vertex. I can go to the table of values. And if I want to see what the output is when the input is 2, it's going to be 3. I can also recognize my vertex and the symmetrical nature of the input and output values, and that can help me graph it. So 1, 1, 3, 1, and that can help me graph my parabola and know what it's going to look like. So my range is going to be from negative infinity all the way up to this ceiling, so all the way up to and including 3. My vertex was 3. My graph, when I read it from left to right, is increasing all the way from negative infinity up to 3, where it changes to a decreasing. My y-intercept for standard form is easy to see because when x is 0, y is equal to negative 5. So my y-intercept is 0 in, negative 5 out. Now for my zeros, I have two ways of writing them. I could write them as ordered pairs, letting me know what values come in that give me 0 out. Or I could say x is equal to the set of these numbers. I don't see zeros on my calculator, so the easiest way is to go to my graph, go to second calc, down to 0, put the cursor to the left, put the cursor to the right. My first 0, I'll round to the nearest hundredth, is 0.78. I'll fill that in as my first answer. My second 0, I repeat the process, second calc. Choice 2, move over to the left, over to the right. And my second 0 is 3.22. When we round to the nearest hundredth, we go to the thousandths place. If it's 4, 3, 2, or 1, we leave it be. 5, 6, 7, 8, or 9, we round up. Alright, so my relative max is going to be the same as my vertex, 2, 3. My minimum does not exist because it continues on forever, on down. If I want to ask if it's 1 to 1, I'm asking it to pass the horizontal line test. And I have a repeat in my range. So no, it's not 1 to 1. Continuous, can I draw the whole graph without picking up my pencil? Yes. As x approaches negative infinity, where is my graph going? It's going to negative infinity. As x approaches positive infinity, where's my graph going? Negative infinity. Alright, next up, my graph is in vertex form. So with my graph in vertex form, I can see my vertex is going to be, remember that's not true to sine, over negative 3, up 1. Over negative 3, 1, 2, 3, up 1. I look at my graph, it's positive, so this graph is going to be up like a cup. When I describe the transformation, it's going to go to the left, 3, is going to go up 1. I don't have an A value, so no stretch, compression, or reflection. My domain is going to be all real numbers. And my range is going to be everything from this vertex point on up. So I have a point of 1 all the way up to positive infinity. My vertex is negative 3, 1. My axis of symmetry is x is equal to negative 3. Let's take a look at this graph on the calculator. Clear that one out. And I'll type it in exactly as I see it. X plus 3 to the second power plus 1. When I graph it, there it is, right where we thought. I look at where it's increasing. Let's go to the table of values. And I know my vertex is at negative 3, so we'll put that. Negative 4 up 2, negative 2 up 2, and this parabola is going to be increasing like this. So it's increasing from this point onward. So it's increasing from my x value of negative 3 up to positive infinity. My graph is decreasing from negative infinity up to, but not including, negative 3. My y-intercept is going to be the output when the input is 0. Two ways of solving that. Input of 0. I can put 0 in here. 0 plus 3 is 3. 3 squared is 9. 9 plus 1 is 10. Or I could look at my calculator and see 0 as an input. It gives me 10 as an output. My zeros, they're none. It doesn't ever cross the x-axis. My relative maximum is going to be none. My relative minimum is going to be that vertex point. 1 to 1, nope. It does not pass the horizontal line test. Continuous, yes. And my end behavior is infinity. Alright, this next graph is also quadratic, but now if you take a look, I'm in intercept form. So in intercept form, I'm able to see my intercepts. I set my little mini equations up and realize that x has a solution of -1 and x has a solution of +5. -1, +5. My domain for this graph is going to be all real numbers. And my range is going to be wherever my vertex happens. The interesting thing about your axis of symmetry is it's going to be the center point in between your solutions. So here's where my axis of symmetry is at. X is equal to 2. And my vertex is going to be an input value of 2. What I need to find is where does this happen? Where does the curve happen? So I've got two choices. I could go ahead and put -2 or put +2 in here. Y is equal to 2 plus 1 times 2 minus 5. So 3 times -3 sounds like -9. If I'm unsure about that, I can always go to the graphing calculator. I can always enter in x plus 1 times x minus 5. I can look at the graph, and I can look at the table of values. I said my vertex happened at 2, so that should be the middle of my graph. And there I have an output of -9. This lets me see my range. So I'll draw my graph. My range is going to be all the values from this -9. So I have my very bottom, lowest point is, box it in. It's included, -9 up to positive infinity as it goes up. My graph is increasing from this x value. My graph is increasing from that x value. So increasing from 2 to infinity, decreasing from -infinity up to but not including 2. My y-intercept is going to be my output when my input is 0. So that sounds like over 0, down 5. And my zeros, that's the easy one. My zeros, I get x is equal to -1 and 5. My maximum is none. My minimum is going to be my vertex. No, it's not 1 to 1. Yes, it is continuous. As x approaches negative and positive infinity, I head towards infinity. All right, page 1, good job.